There we go. I think you're still muted, Professor Peterson.
Yeah, thanks. I said Zoom makes me actually sign into Zoom before I click the link. If I just click the link, it puts me in as a person, but it's a new thing. All right. So what I thought we would do is a kind of a little bit meta in the sense of me both walking you through what I might do if I was presenting this to someone, and for us to be talking, to be sort of like sharing some ideas along the way. So this is recording right now, so I can just upload a recording of everything we've done in this. So what I'm going to partially do is, and I've shared my entire screen with you, so you should be looking at everything on my screen right now. But this is sort of like a lesson plan that or just a version of a lesson plan that I often use for explaining building OS in different contexts. This particular lesson plan I pulled up is for presentations I often give in Energy and Society class, which is a class that Rumi teaches, and they do an exercise. They basically do the problem solving with buildings exercise, and each student in that or not each student, they work in project groups on different problems in that class. So they, in a way, do very much what we're talking about doing. They're obviously college students, so the degree of sophistication is a little bit different. But basically what I do before they get into that is I walk them through different important apps that can be used. So this is not, I have shared with you the problem solving with Building OS handout, which has a lot of the same information here, but this is just a lesson plan that I use, and oftentimes I'm co-presenting with some of my colleagues in that, of just things that we walk through. So this isn't intended for the general public. This is just notes for me as I go through. But basically, I'm kind of more or less walking through the problem solving with Building OS exercise. So maybe for the heck of it, I'll close Building OS so that we're sort of starting with what we would do if we had a bunch of people with us. We would obviously want them to open Building OS, and you would want to have shared passwords for doing that. Those are in this sheet here, but they're also in the problem solving with Building OS sheet. But these things. So if you guys want to get on Building OS right now, you're welcome to do that, or not. You could just watch me do it. But normally, I think you might want to ask people to log in, and I mean, at least that's one option, is to ask people to log in and kind of walk through it with you. We kind of talked about that yesterday, as one option would be saying, walk through this exercise and you can click pause during the video at any point to play around with things. And that's kind of a neat thing you can do with an online exercise, is you can say just pause, and do this. And you could even have questions interspersed throughout the exercise in which you say, pause here, look at a building and identify, a pattern that looks interesting to you, and think about that. You know what I'm saying? So you could have that sort of structured into the video itself. But one of the first things you would do is walk them through logging onto Building OS. And it's a little different for me because it wouldn't pop up like this. It would pop up with a screen that would ask them to log on, and they'd have to enter a username and they'd have to enter a password. And these are good usernames and passwords to use here. We have a bunch of different usernames and passwords to use. Actually, there's a slightly different version of this that's schoolsohio at gmail.com 123, and I think I've shared that with you previously. That's what I used in the class exercise with teachers, and I shared with you in the agenda for what we did with Oberlin teachers links to a version of problem solving with Building OS and energy signatures that use that alternate password, which is probably better to use than this one. I just happen to have this document open. All right, so when you first log on to BuildingOS, you actually have to choose an organization. And for reasons that I don't know exactly how we want to explain, but it doesn't matter, they're going to want to choose the city of Oberlin as the organization. And when they first open it, it won't necessarily open to City of Oberlin. It'll actually open to whatever the last organization that someone logged on through that particular logon account. So it could be any of these organizations. So you're going to have to explicitly tell them you want to log on to City of Oberlin, and when you log on to City of Oberlin, it's going to give you a bunch of different buildings, most of which are located in Oberlin, but the Great Lakes Science Center is one of the buildings that's included in that dashboard. The home screen of BuildingOS has a bunch of stuff on it related to the schools in Oberlin, and frankly, I don't think we want to spend a whole lot of time with them on that because we want them basically to very rapidly get into the Great Lakes Science Center because that's what the exercise is focused on. So we probably want to direct them to click on buildings and then to choose among the buildings the Great Lakes Science Center. But it's probably worth pointing out to them there are a lot of interesting buildings that you could potentially look at if that was something that interested in you, including schools within the city of Oberlin, the fire station, whole city flows of electricity and water, as well as water quality in the city of Oberlin. So there's a lot of interesting stuff to look at, but we're particularly interested in looking at the Great Lakes Science Center. So again, I went from the home, I clicked on buildings, and then from buildings, I clicked on Great Lakes Science Center, and that gets us to a dashboard that has some information, some big picture information about the Great Lakes Science Center, including these bar graphs of total electricity use in each month of the last year, total natural gas use in each month of the last year, and water use. And I don't know why it has this undefined thing here. I don't know why that's showing up, but there it is in the last year. And immediately there are some interesting patterns and differences among the months that might raise some questions about what's going on in the building. You might ask them to think about, what do those patterns tell you about how the building is used in different parts of the year? How and why do electricity and natural gas and water use differ? You probably at some point want to say to them that the Great Lakes Science Center uses natural gas for heating and for cooking. And those are the things that it gets used for. Electricity gets used for a lot of different things, including lighting. Some of it is used for cooling the building, but it's used for lighting, and it's used for all of the exhibits that go on. Water is used principally for the bathrooms and for cooking, and maybe for watering the landscape. I have no idea why water use in June is so high, and that begins to raise some questions. And I also have no idea why, even though we've had some cool weather, natural gas use has not, we still don't see any increase in natural gas use as we move into the cooling season. So I'm already kind of intrigued by those situations. But to be honest, and there's some information about, the building and how much square footage there is, and a summary of, electricity, gas, and water use over the last months. Frankly, I don't spend a whole lot of time on this default dashboard for a building. One of the places I might go pretty early in my looking at a building is into the meters section. And the meters section, and by the way, you guys feel free to interrupt me at any time. I'm not actually showing your faces, so I can't see you do anything unless you talk, because I want to have the rest of my screen open. So you have to say something if you want me to respond. But when you click on meters, what you get to is a page that shows you both the physical meters that are installed within the building that measure electricity use and gas use, and what we call calculated meters, which are meters that may be created as a formula based on other meters. So total electricity use is something that's measured. So this is the total amount of electricity that the building is taking in from the electrical grid. It's important to know that the building is also producing electricity. So if you look down here, there's solar energy. But total electricity is how much electricity is being taken from outside of the building. So it doesn't actually include how much energy is being produced by solar. Natural gas use, I've talked about. Water use, I've talked about. So these are sort of the big picture. What's the building using? And all of these things affect the environment. The electricity use, the consumption of electricity in the building produces greenhouse gas emissions. The natural gas produces greenhouse emissions, and water use too, because it takes energy to make water. A lot of people don't realize that water use has an impact on the environment. You've got to clean that water coming into the building. You have to clean the water going out of the building, and that takes energy and has an environmental impact. Now notice there are a couple variables here that have GHG after them. GHG stands for greenhouse gases. And so this is how much total greenhouse gases in the building are being emitted as a result of electricity, natural gas, and water use. And if we slide down here a little bit, you can see there's also a variable that expresses how much greenhouse gases are being released as a result of natural gas use and as a result of water use. And the nice thing about this meters page here is we can choose to graph anything we'd like to graph. So let's say, for instance, we wanted to start by saying, I want to focus on electricity use, natural gas use, and water use in the building. And I just want to look at what those things look like next to each other and see what kind of patterns I see. Well, if I have the little boxes to the left click there, I can click on graph. And by default, it's going to graph the last 7 days. I can actually choose any time period I want to graph, but just the way the system is set up, it's going to, by default, show us the last 7 days of data. And it does take quite a bit of time to load these things, and how long it takes to load really depends a lot on the internet service that you have. So you got to be pretty patient with this system. If people are really anxious to see something right away, they're not going to see that because it's going out there and finding these data. And sometimes it pops this little screen up and you just say, wait. It's not because it's broken. It's just because it's taking a long time. It's taking a long time because actually we're requesting a lot of data right now. So we've requested 3 points. It's grabbing minute resolution data for that. So you figure it's a minute times 60 minutes per hour times 24 hours per day times 7 days times 3 variables. And I sure can't do that math in my head, but that's a lot of variables. I mean, that's a lot of data. Yes.
Is it possible to take a week span from, say, April or May, not necessarily this past week?
Absolutely, and I'll show you how to do that in a second. So it is possible to do that. Now, there's a few things to notice on this graph. Let's ignore all the spikiness in natural gas use. So let's just forget about the purple line for a second, and just think about the yellow line, which is electricity use, and the blue line, which is water use here. And there are a couple things you probably want to direct them to, either by saying it or by asking them questions. And I think there's going to be a trick in creating a script in which you ask questions and maybe leave time for answers, but obviously you're answering them because you can't, obviously you're not interacting with them, but how you develop a script which would, give them space to think about something. But, what I tend to see is, what I tend to ask people when I guide them through using this is, what explains the patterns? What patterns do you notice in terms of, electricity and water use? And actually, I think it actually would be better not to graph gas use on this thing to begin with, because it ends up being pretty confusing because of the spikiness of it. So if you just had water and electricity on here, and you're going to want to think about what you want to graph that makes things sensible to them. Probably, well, let me ask you guys, what do you guys notice about, again, forget about gas. What do you guys notice about the patterns of electricity and water use, both individually and in terms of their relationship to each other? What do you guys notice?
Well, individually, there's spikes, and I think it would correlate to day and evening whenever the facility's actually open to the public and running and not. I know you mentioned it was closed on Monday. You can see that in between the Monday and Tuesday, which would be Monday day, there's severely less water usage and electricity usage. In terms of their relation to each other, they both have peaks around the same time, pretty much consistently. And then for whatever reason, the electricity peak lasts a little longer than the water.
Yeah, see, those are all really good observations. And thinking about how do you, in a video that is not actually interactive, sort of raise those questions and maybe answer those questions, because you could have the questions pop up and then you could have like answers pop up on the screen too as superimposed things. But, something that a lot of people often, so first of all, one of, I think, the really important things that you said, which was obvious to you, but isn't necessarily completely obvious to everyone, is the amount of electricity and water used in the building is pretty clearly related to whether people are in the building or not, right? So that's actually an important insight for them. Is like it's related to use, and an outcome of that is obviously that people can use the building differently. If the objective is to reduce the amount of electricity and water use, people can use the building a little bit differently. There might be some opportunities here. Another thing that people often, and so you said they're coincident. And that's true, but they're not completely coincident, which you also said, the water and the electricity, which is also true. Another thing people often notice about water is it tends to be a lot spikier, and it tends to go to absolute zero at night, whereas electricity use does not go to zero at night. And so you might ask questions of people, well, why would that be true? Why would water go all the way to zero and be more spiky than electricity use? So I'll ask you guys that question.
By the same token, unless there was a power outage on Tuesday, the GLSC has a really low base load.
Yeah, right. So there's something implied, and you didn't answer my question directly. You're answering it indirectly, but that's an important point to make, is that electricity doesn't go to zero, and that low point is called the base load, right? Because people aren't going to know that. So that's the kind of thing you can introduce, that terminology. We call the low point in electricity use the base load, And this does seem really funky what's going on Tuesday. Because I think they're supposed to be open on Tuesday. They couldn't have been open this week, because there's no way they're not using electricity like that. There's a weird pattern in here that I can't quite, unless this is the start of Tuesday. Maybe this is really Tuesday. But then it doesn't go down between yesterday and today. There's something funky going on, which is worth investigating. This is the whole point. As soon as you look at data, this is why this is a discovery-based process, because you got to look at it. But the nice thing about water in a building like this is that water really indicates occupancy, whereas electricity is often scheduled to come on, like lights are scheduled to come on in the morning at certain times. So electricity has a lot more, management choices in it than water, right? So you see a lot of management, like the base load of electricity has a lot to do with how you're managing the building. You've got emergency lights on at night, which is a management issue. Whereas water in a building like this, if there's no water use, there's no people in the building, basically, And the reason it's spiky is because, like people will get out of an Omnimax theater production or something or whatever's going on. A spike has to be associated basically with a lot of people going to the bathroom or watering in the landscape or something like that. I don't think they have exhibits there that use a lot of water. That's not just not a thing they do, I don't think. So these spikes are really like a lot of people going to the bathroom or a lot of water use for cooking. And right now, I don't think there are cafeterias open. So I think you're basically looking at people going to the bathroom. You were going to say something, Gwen?
No, I was sneezing.
Right. Oh, okay. Right. So anyway, there's a lot of stuff to talk about with that. And the problem with, I'll tell you, there's a problem with the natural gas, which is that it has to do with the way the meter works. It actually is not spiky in its consumption like this. It's spiky in the way it reports to the meter. Like a certain amount of gas needs to be used before it reports gas being used, and then it sends out a pulse. And so it's just reading those pulses. And so it's not a representation of reality. And that's why in some ways, I wouldn't show natural gas on a fine scale because it's just going to look spiky like this. And we're, in the next version of software, we're going to find a way to just smooth that because it's just confusing to do that. Again, you're not going to have them do everything we're talking about now. I'm giving you sort of like a bigger sense of things. We can look at some of the end uses here, like the chiller electricity uses energy used in the cooling system, right? And if we looked at total electricity and maybe if we also looked at solar electricity, unfortunately, the wind turbine hasn't worked in a long time. I'll click that, but their wind turbine's been broken. What are you doing, you dumb thing? Why'd you do that? Did I click add meter? I didn't mean to click add meter. I meant to click graph. Why is it not giving me a graph option here? Where's my graph? Just gonna click this again. Meters, total, chiller, solar and wind. Renewable is just solar and wind added together. I actually think it's not going to be any different from solar right now because I don't think there is any wind production, but we'll see that once it loads these data. And I'm not sure why it's loading so slow. Oh, it didn't load so slowly right now. Let's see, where's the label on this thing? Why is it not giving me a label? Okay, I guess it'll label things when I roll over them. So this is the chiller. This is chiller electricity use. This is total electricity use. This is chiller, and this is solar. So it looks like only one of the chillers is working. But what you can see right here is it is actually using cooling. So it's warm enough still at this time of year that there's a cooling load. So if we looked at this over a longer time period, and now I'll get into next question, which I didn't answer before. You can choose custom period and choose to graph any particular time you want. It's a little bit clunky, but if you do that, you can do it anytime you want. But you can also do very different time scales, and it's worth talking about different time scales. And part of the act of putting together a good presentation is to find some really good stories, by spending a lot of time with this yourself, and then tell those as stories, and then build your exercise out of that. So right now, I didn't do that beforehand. I didn't try to do that. So I'm just doing some real exploration here, and it's a little bit of a more of a mind wander. And the way I'm mind wandering now works perfectly well if you're doing an exercise, you're doing something for a bunch of teachers. But obviously, if you're trying to create a terse 5 to 10-minute video, you want to have everything planned out and make everything count. That's a little different than a workshop. But so this is total electricity use, this yellow line, and it seems to go. It went way down in March and stayed down until June. Why do you think that's? Why do you think it went? Why do you think total electricity use did that real plummet there?
Place closed because of COVID.
Exactly. That's COVID. And the interesting thing is it took a while to ramp down, even though the museum, I think, probably straight up closed here. It seems like they didn't fully, shut the place down electrically until later. And you get this other sense of this is sort of daily base load where they probably still have lights coming on. They probably could have done a lot better job of minimizing energy use beyond that, but it probably just was no kind of priority in their thinking. But they probably should have. They could have saved a lot of money if they'd really tried to conserve more energy during this period. But my guess is they had staff working. They just didn't have kids there. You can tell that the solar panel is pretty token from this because this solar at the bottom is such a tiny, tiny, tiny fraction of the energy use in the main array. That's not true when the wind turbine's working. The wind turbine actually sometimes produces more energy than the building is using, and it actually exports onto the grid, but it hasn't worked for over a year at this point. But when we first installed the system, if you went into the historical data, you would find periods of time when that building was exporting power onto the grid. On a windy day, it would actually send power out onto the grid. But interesting to me that there's the chiller. So the chiller kicked in June. So the chiller, it's not surprisingly not operating all winter and then is operating here. So, some of what we would call sub-metering, which is lower than the main level metering, so you can see both of the chillers. And I don't know what the difference is between what spaces the chillers are using, but it's, air conditioning, basically. And you can see the two of them are interestingly kind of different from each other, which for reasons I don't really understand. But, again, there are a lot of questions you could raise about that. I was going to point out that we do convert electricity and gas and water use into greenhouse gas emissions. And so this is a pretty unusual thing you can show them, which is greenhouse gas emissions from different end uses. And I don't know whether it's going to graph 7 days or because we've selected this year, it's going to stick with a year's worth of data. I'm kind of hoping it sticks with a year's worth of data. Usually I find that it likes to default to 7 days whenever you do anything. And like I said, it may be that when you create your video, you're going to want to just kind of like cut out. Actually, you probably will want to cut out the loading time and just, maybe say to people, don't worry if it says it's loading. It's going to load, but it takes some time. So this one is, this blue one is greenhouse gas emissions associated with natural gas use. And the purple one is greenhouse gas emissions associated with electricity use, which is mostly higher than gas. But you can see gas use completely drops off at the end of May. And that's two things going on there. One is you're at the end of the heating season, but the other thing is you close down the cafeteria, which uses natural gas. And they evidently really have basically yet to turn it on because there's almost no gas use even till October at this point. I think normally you would have seen it throughout the year because of the cafeteria use, but it's obviously related to heating, which is, interesting and important. You can see that for water use, water consumption in the building is a very, very small piece of its total greenhouse gas emissions, which is not to say that it's unimportant. At any rate, there's a lot of stuff you can do with just this meter section here. But I've basically covered all the different things you might do. And then obviously you can look at, different time intervals and, do a lot of different things with that. But the next thing to focus on is what's listed over here as apps. Apps stands for applications. And they provide a lot of other ways of visualizing data. So this particular visualization is called a time series graph. And you guys know that, but I'm kind of explaining it the way I might explain it to other people. A time series graph graphs the amount of something versus time. It's that simple. And so you're seeing a pattern of how something varies over time. And so for this, we see this pattern of high natural gas use in the winter months when it's cold because it's used for heating, and then decreasing as we move towards spring. The whole thing here is a bit artificial because this is COVID, so it's a little hard to say exactly what that's about. But we do see distinct patterns in electricity use too over the course of a year. And I think we're really seeing the opening up of the Science Museum here, but why we're going down, I don't actually fully understand. But the apps provide other ways of visualizing data. And this way of like taking numerical information and turning it into a visual form is one of the most important aspects of the way scientists work. They take information in numbers and they turn it into patterns that you can see to help you explain the way the world works. So that's a very important explanation to do for people when you do this, because that's really what this is about, is using data visualization as a way of better understanding quantitative information about resource use within that building. So when I clicked on apps, I have a choice of a bunch of different analytical tools here. And I want to show you several of these. My all-time favorite, and the one I'll go to first, is called heat map analysis. So if I click on this app, it's going to open another data visualization tool. And by default, it's opening something that's about schools. And since we're focused on the Great Lakes Science Center, I don't want it focused on schools. I want it focused on the Great Lakes Science Center. So I'm going to click the Great Lakes Science Center. And right now what it's focused on is information about chiller number 1. And it's just kind of doing this alphabetically. That's how it makes its choices. So it's not like it's giving me things it thinks are important for me to look at. It's just giving me things. And actually the chiller number 1 could be a really interesting thing to look at. But I'd like to start by looking at a bigger picture thing. And so I think what I want to look at is total electricity use as the first thing I look at. And I actually feel like I want to look at it not just over 6 months, but over I'll look at over the last 12 months. So that's giving me a year's worth of data, but a year starting from today and going backwards. And I think, yeah, okay, let me talk a little bit about how to interpret what we're seeing here. And I might change this from degree days to outdoor temperature just because it's a little bit easier for a lot of people to interpret outdoor temperature than degree days, although they're very closely related to each other. Okay, let me explain how you interpret this particular data visualization. So this graph is also showing patterns of use of a resource over time, like a time series graph, but it's doing it a little bit differently than what we saw before. So think about this. Every column here in this display is 1 hour of the day. Every row here is 1 day of the year. So if you look at an individual cell, let's say here, this little green block right here, the tiny green block right here that I'm rolling over, that is 1 hour of a day in November. So that's the way to think about this, is it's 1 hour of a day last year in November. And if I roll over it, I'll find out exactly how much electricity was used during that hour. 105, where I am right now, is using 105 kilowatts of energy. That was the rate of electricity consumption during that hour. But what you notice here is that there are these sort of color patterns. So the color relates to green means much less electricity use, dark green. Red means a lot of electricity use. Yellow is intermediate. And so you're seeing these sort of distinct patterns of electricity use over time. And what I would typically do is ask people again, just like with the time series graph, to sort of explain the patterns they see, how the patterns sort of change over time and what they might be saying. It looks like there's a period where, looks like between 8 in the morning and 5 on most days, there's a relatively high level of energy use, with some days when there just isn't any energy use. And so you might guide them in sort of suggesting reasons why the pattern might be there. And my guess is what do you guys assume about a day when it's green the whole day?
Building's closed.
Yeah, the building has got to be closed on those days. Those actually tell you something about management, because the fact that it stays dark green the whole day means they probably did a pretty good job with the building automation system of not having a lot of lights go on days when the building's genuinely closed. You can see some patterns within this, like there are greener days, and my guess is maybe those are Mondays. There's still staff there, but there aren't people there. So there are some patterns there. You can see this whole big green period here between March and May. And what's the explanation for that?
COVID.
Yeah, exactly.
And then that one white cell, the meter probably broke.
Right. If it's white, no, people will ask you questions about that. That means it didn't return data. So that is actually non-data, no data. You can see I popped over it, no data. So that doesn't mean anything except that for whatever reason we didn't capture data. But you can see once they started in again in June, you had these days in July and August that were really dark red, and they really dominate the whole year. I mean, those days in July and August are way higher than any electricity use that ever happened in November through those days. And and then it's sort of down again now. Why in July and August? We know that the Great Lakes Science Center actually wasn't that used in July and August by the public. It was still kind of closed. Why do you think what explains that huge energy use in July and August?
Air conditioning.
Absolutely. And that's why having temperature graphed here is so cool, because you can see that that's totally related to outdoor temperature. And that's a really useful thing to explain to kids, because it's like they begin to see this relationship between what a building is using for energy and outdoor temperature. You can draw connections between that and climate change. So when the climate gets really warm, we're actually going to be using more electricity. And that's kind of something to think about. So that's an interesting thing to think about. Interesting to contrast that with, let's say, total water use in the building, and see what that looks like over the last 12 months. And here, presumably you wouldn't see much of a relationship with outdoor temperature, and it's you do see that, obviously use during the day. You've obviously got certain days when you had huge levels of water use, and useful to have them to sort of speculate on that. My guess is they had a leak here, or they were doing some kind of activity that was just consuming. 947 gallons of water per hour in a building that basically only has bathrooms. That's kind of crazy. That's a lot of water. And then this one occurring at night, they had 1,253 gallons of water at 8 p.m. to 12 p.m. I think they had something wasn't working there. Something was
call the water company.
Yeah, something's wrong there.
The plumber.
Yeah. This is interesting. In June, they must irrigate the landscape. I have no other explanation for why you'd get this yellow, or they had a low-level leak the entire time. Because they're using 411 gallons of water. This is really interesting. This is what I'm talking about. This is where the detective work comes in. It's I don't know what's going on there, something funky. That's really funky, that pattern. There's something wrong. And it fades in. Notice it's fading in. So it seems almost like they're like tuning things down. That's what makes me think maybe it's more, maybe it's irrigation. But, you know, you could potentially have them construct a series of questions for building managers or something about what's going on there.
I know you mentioned in the proposal that we should collaborate with Scott. Would this be to the means of, all right, we see this trend. Do you have any insight of why we might see this trend in June with the water usage? Is that something you would know necessarily?
It could be. It could be something that he'd know and that you could then sort of incorporate into your exercise and say, you know, this is what's going on. So yeah, it could be. I mean, I would kind of like have us get pretty far with the script and what we're planning on doing. But yeah, you know, I mean, certainly we could shoot him an email and say, hey, you know, we noticed that there's this super high level of water use between basically the last day of May and the first week of July. You know, do you have any explanations for that? You know, so yeah, we could do that short term. Now I'm going to switch to natural gas, but before I do, what would you expect natural gas to look like? Given what you know about natural gas use in that building, what would you expect natural gas use to look like in terms of patterns? What would you expect it to be related to, for instance?
Definitely heat, because it's the source of heat.
Right. So if it's related to heat, what is it going to be? What else is it going to be related to?
Sure.
How
Outdoor temperature, exactly. So that's the one that you might actually, I mean, you've got a strong relationship between hot days and you know, electricity use, and you would expect a strong relationship between, I'm looking for cold days here, and gas use. But here's where we can sort of begin to, you know, figure out, has it just not been cold enough this year for them to turn on the heating system? Because I'm kind of like confused by the fact that we've seen no gas use yet this fall. I mean, it makes sense from a restaurant perspective because they're not serving food. So, oops.
Oops.
BuildingOS is a little buggy that way too, so you just have to kind of roll with it and maybe even tell people, you know, reload if something happens. Huh. Yeah, I'm definitely seeing like here you see this real dip in temperature and you see this band of heating. Here you see that same dip. You know what I'm saying? Here you see the same thing going on. So you definitely can see that situation going on. It's funny, they had a really hot day in early March, reaching up into the 50s. But then there's just nothing after that. But you know, you can do this same thing with sub-meter. Well, actually, let's look at solar energy production. That's probably an interesting one to look at too. So what would you guys expect to see in terms of pattern here? I mean, now you're looking at it, but you know, not surprisingly, in the winter, you have less overall production. You still see this pattern of like, you know, highest production around noon when the sun is highest in the sky. But you also see a pattern of, you know, this is kind of cool. This is kind of cool from an astronomical perspective. The band in the winter is between 8 and 5. And then as you move into the summer months, not surprisingly, that whole band of production moves out to 6 a.m. to 9 p.m., you know, around the summer solstice. And then it's getting narrower again. So you got like all that embodied in here. And it looks like we've had some great September days for production. And by the way, this really high production here associated with a decrease in temperature makes sense because solar panels are actually temperature sensitive. So they produce more electricity when it's cold. So it's a combination of both sunlight and temperature. So this
might also be a cold front coming through.
Right, but my point is it's the temperature. The cold front would be affecting the temperature. The cold front isn't going to affect the light energy. It's only going to affect the temperature. So
Yeah,
that's why.
I'm just thinking along the lines of cold fronts tend to be high pressure with better chance of being sunny.
Oh, right, right. But I'm just saying you get that like band of real high production. Oftentimes you'll see that in May. And you'll get like oftentimes, you would think June 21st from a sunlight perspective would be when you should be expecting your peak production. But your peak production actually often happens in late May when you're still getting cool days and a lot of sun. That's what we've seen in the solar array. Anyways, but you can see that bulge here, which is kind of cool, which is, reflects the narrowing and the, so there's a lot of stuff to be said about that potentially. And, again, we could look at an individual chiller, which is what we started with, and presumably that's going to be totally related to hot days. And that's what we see. That's an interesting one to look at. That's kind of cool looking. All right, so the heat map is a great one. When we look at like the city or something else, we're often looking at multiple buildings at the same time. That's not really true for the Science Center. So some of the apps, like one of my favorite apps is this portfolio drift, which is where I usually go first, but that's actually not relevant to the Great Lakes Science Center because it's about comparing buildings. And for the schools, this one could be like a really critical one to show because you can compare energy use among schools, the different schools. But for Great Lakes Science Center, it's just not relevant. So I'm not going to sit on that now, but I will say as we think about an exercise that you could begin to translate into something for schools, this app becomes really important, as does this app, which compares different buildings. But for us, really, it's simpler than that in the sense that really the most useful things are looking at the time series graphs that you can look at in buildings, the way we started this, looking at heat map analysis, and then also the other one that's interesting is load profile. And this is actually I'll use the word buggy. It's kind of the buggiest of the apps because it loads a lot of data. So let's look at Great Lakes Science Center here. And let's not look at chiller. Let's look at total electricity use for that facility. And we can look at the last 30 days. By default, it does weekends, which I think are not actually the right thing to have as a default. I think weekdays are much more interesting. So what this is doing is it is graphing all of the last 30 days of weekdays on top of each other. And it's a useful app because it gives you a sense of recurring patterns in use over time. And so this orange line here is the average of all of those times, and the red is sort of the outward maximum of all those times. It's not a particular day. It'll trace one day, and then it'll trace it'll always trace the highest line, and then the minimum is tracing the lowest line. And I mean, there are patterns here. This is often really helpful for understanding building management because patterns that recur every day at the same time tend to really be indicative of sort of management as opposed to more than human behavior. Like you can see this really characteristic drop off between 4 and 5 p.m. And so there's something, or 4 and 6 p.m., where almost every day it seems to be this steep drop off in energy use between that, and then much more consistent. Interestingly, it looks like there are two different patterns for weekday data. There's this one and there's this one. And that might be telling us some things that are sort of pretty specific to the Science Center. Can you guys think of any things that might explain why if you took the last 30 days of weekdays, you might get two different common patterns?
Maybe there's something that goes on in the evening some weekdays, but not others. Also, I need to go really soon.
Yeah, I think you're right. I think that's what it is. It's there's things happening some weekdays and not others. And maybe it has something to do with Mondays and Mondays it being closed or between Sundays and Mondays. Although actually this is just weekdays. So I think it has to do with certain evenings must be open, and you can see a little of that coming in on this end too. And then, you're probably the lowest rounds here are probably Mondays. I think we've covered a lot of what I would have covered in this. I guess the only other interesting app that might be worth looking at is it's not radically dissimilar from what you can do looking at individual meters, but this app that I just clicked on, which is the trend analysis, looks at an individual meter in the same way we did before, but it does have some interesting summary statistics on it. So if we go to Great Lakes Science Center and total, let's say total electricity use, it's going to graph just that variable. Again, it's kind of a variant of what you can do when you go to meters, but it does below it, once it loads, it'll load. Oh, it's funny, it switched to greenhouse gas emissions. Don't know why I did that. Total electricity use last 7 days. But the summary statistics underneath it are interesting in this. So that's patterns of electricity use. We've kind of seen that already, but it's kind of summarizing how much money was spent on electricity, how much money was spent for just to support base load, etc. So it's got that added feature to it. But at any rate, I think that between those three, between meters and heat map analysis and load profile analysis and trend analysis, I think those are basically the tools you would want to explain, and you'd want to sort of explain it in the context of telling them a story about resource use and greenhouse gas emissions that leads them to be able to conduct some sort of independent work on it. So yeah, since we need to wrap it up, maybe I'll go ahead and wrap there. And let's see, let me get back to my controls. Why can't I get my controls back?
I think I'm just going to go. I have a lab in less than 5 minutes.
That's fine. All right.
See you guys. Thank you very much, Professor.
Yep.
Bye.
All right, Nick. Let me stop share. Right, that's what I want to do. All right, so we're out of that, and I'm actually gonna